formation for any pure element in its natural state is 0. And so you'll also find in the appendix a state of Gibbs free energy values, standard Gibbs free energy of formation for many, 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 many compounds. And if told to find free energy that way, that is a perfectly acceptable way to find it. However, that is not the only way to find it. All right. All right. So if the state of a chemical system is such that a rearrangement of its atoms and molecules would decrease the energy of the system and K is greater than 1, then this is a product favored system. And that should make sense. If we decrease the energy of the system and K is greater than 1, then both of those things together definitely mean that it is a product favored system. Okay. Most, and again, sorry, I can't see that. That says most product favored reactions are exothermic. But remember, we said that this is not the only criterion. We're going to find out that we have to take into account both the enthalpy and the entropy. Okay. So whether something is exothermic and has an equilibrium constant that is greater than 1 is not the only criterion for whether a reaction will be favored. Both product and reactant favored reactions can proceed to equilibrium in a spontaneous process. So here we've just studied case of SPs. We have silver chloride giving silver ion plus chloride ion. Our K is 1.8 times 10 to the negative 10. We would have to agree that this is a reactant favored equation. So the reaction is not product favored, but it does move spontaneously towards equilibrium. And so spontaneous, again, does not imply anything about the time for reaction to occur. It also doesn't imply anything about whether we have a product favored reaction or a reactant favored reaction. Okay. Okay. So let's make a technical definition for a spontaneous process. A spontaneous process is one that can occur in a system left by itself. No outside action is necessary. Now, I just want to say one thing. If any of you have a propane grill or have ever seen one in action, if you just open up the gas, what happens? The gas starts to come out, right? Does it burst into flames? No. What do you have to do? You have to give it a spark. Now, do you have to keep sparking it? Okay. Now, conversely, if you have to heat something up, so when you boiled water in the lab, that wasn't just a little bit of heat you gave it and then it was boiling water, right? You know, you had to continuously supply the boiling water. So when no outside action is necessary, some reactions may require a spark or some small little event to get them started. However, that does not imply that that is outside action, okay? That just implies that you have to spark them somehow. Your gas grill, once you give it that spark, what does it do? It continues to, what? Do its thing, right? Until there's no more gas, if you don't shut off the gas. All right, so our examples, ice melting at room temperature. You don't have to do anything to ice. Non-spontaneous processes will not take place left on their own. Action from outside the system is necessary in order for these processes to go. And again, just to make sure, you can probably already tell that this is a confusion for students. Spontaneous implies nothing about kinetics. So again, we could run the thermodynamic numbers, show that rusting is a spontaneous process, and you could wake up and say, hey, my car hasn't rusted yet. It's going to take a long, 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 long time for it to happen. If a reaction is spontaneous under given conditions, the reverse process is non-spontaneous. Only spontaneous processes occur naturally. Spontaneous processes are not reversible. Alrighty. All right. So here's my diamond. Diamond is thermodynamically favored to convert to graphite, but, so diamond is thermodynamically favored to convert to graphite. Nobody's worried about their diamonds because it's not kinetically favored, okay? Paper burns, that's a product favored reaction. Also, it's kinetically favored once the reaction has begun. Now, what is this kinetically favored once the reaction has begun? Meaning, a piece of paper is going to sit there for a long, 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 long time. It's not going to just burst into flames, correct? So in that particular case, it's not kinetically favored. Once we light the paper, though, it is kinetically favored once the reaction is begun. So all things being equal, there's no strong wind, blah, blah, blah. Once the reaction begins, it will be kinetically favored as well. And again, in general, spontaneous reactions are exothermic. This is the thermite reaction. This is an industrial process for getting pure iron. Iron is reactive enough that when you can smelt it, but you can also get pure iron using what is called the thermite reaction. It's highly exothermic. That's a lot of sparks going on there. I've done this, and if you do it, they recommend that you do it in ceramic pots, and they all always crack because it's just such a high temperature. So, many spontaneous reactions or processes are endothermic or even have a delta H equal to 0. We're going to talk specifically about the delta H equal to 0 a little bit. So here, this is some of your cold packs are actually made from ammonium nitrate. All right, if you will put that in water, as I've said before, you observe it getting cold, okay? And so why does it get cold? Where does that heat come from? The heat comes from the surrounding